I am a PhD student, as it was told before. So I'm from Kazakhstan. This is our institute. It's situated in Almaty city, the former capital of Kazakhstan. Today, this is outline of my talk. Today, I want to give a short talk about new area for us. It's aqueous extraction of organic part of oil sands under influence of ultrasound. And also, I want to show you our small pilot installation for continuous extraction using ultrasonic treatment and alkaline additives. So the actuality and introduction is that one of the most important achievements of recent years is the creation of technology for extraction of heavy oils from oil sands. And as the best example can be Canada, which has already factories and has a very good results with oil production from oil sands. Venezuela, Russia, Kazakhstan has also huge deposits of oil sands. But unfortunately now in Kazakhstan, since we have conventional oil, nothing is doing with oil sands. So during our research, we are pushing our country, our government to start some work with oil sands. So actually oil sand is a natural combustible mineral material. It mainly consists of two parts. First is mineral part and second is organic part. Mostly oil sands deposits are concentrated in western Kazakhstan, and if we can separate oil and sand, we can use the organic part as a valuable product which can be used for road construction. I want to add that Kazakhstan is the 9th biggest country in the world, and now we have a big program for road construction, and if we find technology, we will make the price of road construction much lower. So, as my mentor, Professor Mansurov, told yesterday, we have about 50 huge deposits of oil sands. And what is interesting, the organic content ranges from 5 to 95%. As I know, in Canada, it ranges from 9 to 16%, and we have even 95. It's depending on the depth of the deposit. In ICP, we have a special laboratory which is doing research. So we are doing it in 3 ways. First is the extraction using organic solvent. Second is the thermal processing with obtaining of synthetic oil. And I want to focus on our third way processing. It's the ultrasonic processing of oil sands using aqueous solutions of alkaline metals, and they serve as surfactants. This is just a small review. This is a scheme for installation for organic solvent extraction. Different hexane, toluene, benzene, different mixtures can be as a solvent. And the installation is very simple. We have a reflux condenser, we have a Soxhlet apparatus, and we have a flask where the solvent with oil, with extracted oil is coming. So we boil the solvent, it evaporates and condensates, and the droplet of solvent comes to the oil sand and extracted. After that, this natural bitumen extracted can be oxidized, and we already did this work. Last year I was presenting this work in Las Vegas, and after oxidation, our natural bitumen has very close to the standards, by standards to the bitumen which is used for road construction. Also, it's just a small review. We are doing thermal processing of oil sand. The temperature is about 600 degrees. It's a lab installation and pilot installation. So, and we start to do the ultrasonic treatment of oil sand. We start, on this slide, you can see a simple installation for ultrasonic treatment of oil sand. So we have a oil sand which is in aqueous solution. We have a source of ultrasound which makes a cavitation, and during the time the oil droplets start tears from the surface of mineral part, and we can collect them on the surface. But it's also very important to understand the mechanism of separation oil and sand, and we found a very good publication where this mechanism is described. So as you can see on this figure, during the ultrasonication, nuclear cavitation nuclei with bubbles are generated, and these nuclear bubbles, cavitation centers, can produce the microjets. In its turn, these microjets impacts and the surface and erode the surface and tear us from the surface small particles of oils. And in the effect of ultrasonic field, these small particles of teared oil can condensate and turn into larger oil droplets. This is a mechanism for separation oil and sand. So we started our experiments from laboratory and tests. So we have a simple installation. It's ultrasonic bath. I believe it was Sonar X. So this is a characteristic of this bath. And we have a special container where we put sample of oil sand. This was water. And we tried to ultrasonic treat it in the range of temperature, increasing the temperature from room temperature to 70 degrees. And we found, first we wanted to find what is the best temperature for processing of oil sand. We had two types of oil sand, two deposits, it's BK and Muneli Mula deposit. I want to say from the beginning that this cannot be used the same for each. It depends on the nature of each oil sand deposit. So if you're processing oil sand of certain deposit, you have to know its nature. For this oil sand, we found that at 70 degrees, we have the maximum yield. It was about 2%. Further increase the temperature didn't show us any better results, so we found that the optimal temperature is 70 degrees. But the yield was only 2%, and it was very low. And we start to think how to increase the yield. And we found that with additions of alkaline metals, which serve the factors of its influence, they have three factors. First, they make the neutralization of organic acids, followed by formation of natural surfactants in the form of soluble salts. Also, they increase the pH of the medium and the change of the electrical charges on surface. So, with addition of surfactants of alkaline metals, with addition of alkaline metals which form the surfactants, we decrease the adhesion between bitumen and sand, we increase the lithophilicity, and we also decrease the surface tension between bitumen and water and oil. And this is a process of separating oil and sand becomes much more easier. And we started to study the influence of different concentration of alkaline additives on the output of the bitumen, organic part. So, as you can see from this picture, the higher concentration we have, the biggest output we had. So, in laboratory, we can reach about 84 mass% output of oil sand, and we used sodium silicate as an alkaline additive. Also, we used sodium hydroxide, sodium carbonate, but for this oil sand, sodium silicate was better. After we found some details about how to do that, we wanted, laboratory tests are good, we can do the separation, but it was interesting for us to see how can we scale up the installation and see how it will be working in scale-up installation. So we have researchers in our institute who counted everything and made a scheme for this installation. This is a real picture of installation which was used for ultrasonic purification of separation of oil sands. Actually, it consists of three main parts. First part is a chamber where oil sand and alkaline solution are mixed, and it's making a pulp mixture. It's mixing for a while and make a pulp mixture, slurry mixture. It should be very slurry. After that, it's pumped to the second part. It's ultrasonic treatment part. We have an ultrasonic source here, and this slurry is ultrasonicated here for a while. It depends on the mass of oil sands that we are try to separate. Usually it takes more than 1 hour, 1-2 hours, and it also depends on the nature of oil sand. And after that, it goes to the third chamber. This chamber is cyclotron centrifuge center. Here we, due to cycles and centrifusion, we separate it. So the sand goes down and the organic part is going to the containers. But not only organic part, there is a mixture of organic part and solution, working solution. And this installation is for continuous. You can reuse the working solution several times. And that's why we also choose the high concentration, because when using working solution with a high concentration, it can be used for several times and more efficient. This is just for your simple understanding. So we used this ultrasonic emulsifier. I just put the picture of it, and you can see some characteristics. What we used, I think we could use more powerful, but we had this one. It was 100 watts. And this ultrasonic emulsifier is on installation is here. You can see it here. It's inside of this chamber. So, and we try to separate in our pilot installation oil sands of 2 deposits. It's Munali-Malai and Beke deposit. So as you can see from this slide, the temperature in both was 70 degrees. It's an optimal temperature, and the concentration of alkaline additives was 12 mass %, and we reached about 90-92 yield of organic part from both oil sands. It was pretty good results for us. And at the end, I wanted to show you, for your better understanding, the pictures. First picture is the sample of oil sand, so it's represented by mineral part and organic part. Second is, I said, we are doing thermal processing of oil sand, and this is the residue after thermal processing of oil sand. This is a coke sand, coked. It can be used for further investigation as a hydrophobic sand. I think now it's this theme is very also important. The third picture is a sand which we received after ultrasonic treatment with alkaline addition reagents. And the fourth is a picture of sand which we received after solvent extraction of oil sand. You can see that sand is much lighter and this is a little bit darker. So we have some residue of oil on the surface of the sand. Of course, extraction is much more better. It's close to 100% separation, 99%. But the problem is that it takes time. For example, 300 grams of oil sand can be extracted for 2 days. And this process is much faster, and we can obtain about 90%, what is really good. Maybe in future we can increase the output, changing the capacity of our ultrasonic treatment, and maybe some different alkaline reagents. So this is my talk for today. We studied the kinetics and efficiency of separation of oil sands. We found that addition of alkalines and increasing the temperature are very important for make the better separation. We found that it's better to use high concentration working solutions. They increase the output and they can be reused, what is good for economical and environment characteristics. And we just show that there is also one additional way for processing of oil sands, which can be count as alternative. Thank you.